Hello, everybody. Welcome. Welcome again to the Learning Kubernetes series where I, Marko, am learning Kubernetes. So far, we've gotten through KCSA in the past previous episodes, and I've started preparing for KCNA. Now, for the last 2 weeks, I had to unfortunately pause the live streams because my voice had gone, and without a voice, can't really talk about much things. My voice is almost completely healed, so excuse me. I will be talking today about the progress I've made on the KCNA, and that's going to be number one. Where we are with the KCNA, I think the exam prep app that I've been building for KCNA is in a good position to get myself and anybody who wants to use it to situation where they're ready to where they're prepared to take the exam, where they have a high probability of getting through that exam. I'm hoping that I will be able to pass with that exam. And then in the second part of the episode, I'm going to show you a little bit of an experiment that I'm working on, running on Kubernetes, looking at a little bit of security for our AI assistants. You probably all want to run your AI assistants. And we've heard recently news from even Anthropic that when they run their models, they run them in a sandbox environment. They don't just allow them access to everything. So if the vendor is running their own model in a sandbox environment, I think we should too. I think we shouldn't install it onto our computer and just give it access to everything, because that is a powerful thing. So, lesson learned, let's make it more secure. For now, let's turn our attention to my screen share here, which is going to show up in 1 second. All right, so there we go, and there it is. So Kubernetes exam prep app right now, super easy to install. You need rich, super requisite, and then just run the Python. If you're on Windows, run bat will get you there after you install rich, because Windows has this really weird UTF-8 thing, so I had to create that thing. So previously, KCSA with 240 exam style questions. I had 160 when I went to take the exam, and those 160 got me through the exam for a pass. But I did add another 80 questions first, because I wanted to make sure that there are questions that I actually saw in the exam. And second, to rebalance a little bit the difficulty of the exam. I think I made the questions slightly too difficult, and there are so much easier questions on the actual exam. There was one of my live stream attendees said they used the questions as well before the exam, and they found that the exam was actually more difficult than my questions. That's a strange thing, but again, they passed. So still works. Learning works, right? And here we're using AI to learn. These are AI written questions. They're just written in a JSON file, and then that JSON file is pulled in for our main component when we run the actual Python. So now I've added KCNA. What happened now? KCNA? I seem to have lost. I'm back at the main branch. Okay, I'm back at the main branch. So let's go git switch KCNA exams, KCNA labs, gyot. That's typo there. All right, we should be KCNA labs now. And if we check out what's going on, there we go. Yeah, okay. So this is in a branch. This is in a branch that hasn't been committed to the main repository. I'm still working on it a little bit. But now I have 300 exam-style multiple choice questions, detailed explanations, and documentation links. I have 10 hands-on Minikube lab challenges, so you can prepare yourself if you need more hands-on experience. I definitely do need more hands-on experience, and I've found this to be useful. And then progress tracking across sessions. So let's try it out. Run bat see how it works. I'm going to push up this terminal a little bit up. There we go. It's time to try out the KCNA. What? 2. Exam practice. So in exam practice, we'll do all domains. In exam practice, I've done a big setup with Quick, which just gives you 20 questions to test the capability. Full, which gives you a full exam experience, meaning all 60 questions like you would have in an exam, and then all, which gives you all 300 questions that are available. So I'm going to go for Quick just for fun. Randomized question order. Yes, this you should definitely randomize question order. Otherwise, we're just going to go from 1 to 3 to 4, etc. Unless you're doing all, you can just go through all questions themselves. All right, randomize questions. Let's see. In a deployment, which strategy type is used by default? Recreate, rolling update, blue-green, or canary? What is the default strategy that is used by default? I believe that recreate is the default strategy. Let's see if A is correct. Incorrect. It's B. Rolling update is correct. There you go. I haven't gone through all of these questions, and I really haven't studied that much for the KCNA. So this helps me study. Rolling update gradually replaces pods in the default strategy. Recreate replaces all pods at once, not default. Blue-green is a deployment pattern, not a built-in strategy. And canary is a rollout pattern, not a native strategy type. And then takes me to the docs, and I can open up the docs, and we can see where it takes us. It takes us to the rollout strategy, rolling update deployment. Yeah, it's going a little bit too low, but still, it's got the capabilities that we have. And I'm not showing that on the screen. Let me just replace that with the entire screen. We'll just go entire screen. There we go. Much easier for me to just switch. And there we go. So rolling update deployment is the default, and that's where this link takes us, right? So if I click it again, it should open up my browser. And it seems to open up my other browser, but hey, we got it. We got it. All right. Enter for next question. Let's go. Service mesh like Istio provides MTLS between services without requiring application code changes. Which component is responsible for enforcing this encryption? The Kubernetes API server, which terminates TLS for all pod-to-pod traffic. The data plane proxy, like Envoy, injected as a sidecar into each pod. The CNI plugin, which encrypts packets at the network layer. The core DNS server, which issues certificates to each service. Now, I don't know. I think that probably this is going to be done through the CNI plugin. I'm not really sure. So I'm going to pick C. Am I correct? The answer is B. The data plane Envoy injected as a sidecar into each pod. There we go. In a service mesh, we inject something like Envoy into a sidecar into every pod, and the proxy intercepts all inbound and outbound traffic and enforces MTLS. The explanation is right here. Where does the beautiful thing take us? It takes us to Istio. Takes us to Istio, to the high-level architecture, and there we go. That's our proxy. That's our proxy in there. All right, next question. Hope I get some right. Which field in a deployment pod template can be used to set environment variables from a config map? And from env, config map ref, or volume mounts. I think it's C. It's incorrect. It's env from imports. Oh, imports. Okay, fair enough. Fair enough. And this is essentially what what we're doing with this tool. We're trying to not just give you a challenge, but also give you explanations. Me, we, I, Marko himself. All right, that is it for now. We'll terminate this batch. And this is something that I expect to deliver. The branch is going to be merged into the main soon as soon as I do all the fixes that I want to do. So In the next update, we'll have 300 exam style questions. For now, this is it's exams. There we go. For now, this is stored right here. So if you wanna grab your copy of the current version does not have KCNA, but if you want to grab your current version for the KCSA, grab it right here, or wait a few days until I get to I think version 0.22 will be the version that will actually have KCSA, maybe 0.30. I probably should do a minor here since adding KCNA is quite a big deal. Adding KCNA is going to be quite a big deal. We'll turn it into 0.30, and that will be the next step. Now, while I've been away, I've also been playing with something else that was really cool, and that is OpenClaw. I was recently at a KCD, and we were talking about, we were talking with the attendees of the community days. Hey, Kubernetes is cool, but you know what's even cooler? It's AI. And we were like, yeah, sure, AI. And then one of the attendees there remarked, hey, you know what? I'm really not going to put any of those agents in my network. I don't know what it does. What does that thing even do, right? What does that thing even do? Well, that got me thinking. Like, what does it even do? How can we see what it does? Well, I've started working on something called the OpenClaw network boundary. This one is running on Kubernetes right here. This right now is not yet a public registry repository, but it does go from the network boundary stack. And the network boundary stack project is already available live. So this is the base from which it's designed. So I'm just going to grab that. These are our labs on Dev Central. And the core idea is basically we want to have OpenClaw, but we want to make sure what it does. So I'll just switch to the other repo. So what we're doing is we're capturing everything in Nginx. We're feeding that forward into OpenClaw. And then every request that's received by Nginx creates an OTel record, OTel inbound record, not a span, a record. The span is a full set of records. And then once OpenClaw responds, iptables blocks it and directs it to HTTP proxy. So we're using Nginx HTTP connect capability, which was released back in May in version 1.31. So we're doing a forward proxy to the internet so that we can capture all activity from that Nginx, from the OpenClaw through Nginx. So it's really simple. It really simplifies the deployment. And then, of course, we get the OTel outbound spans to see what it's actually doing. And then we can feed that to an OTel collector. And then that turns into this network boundary traffic JSON file that we can take a look at then. So essentially, I'm running Olama. I'm running on a small little laptop. And then we can take a look at how this works. So basically, we got our OpenClaw here. And in our OpenClaw, we can say, hey, look up Nginx on the web. Look up Nginx on the web. And you'll see that should be an allowed capability because I have added a search engine into OpenClaw. I've added DuckDuckGo. And we'll see why. Ooh, tool web fetch. Google.com is wrong. Google should not be allowed. That is actually Nginx rules working as they should. So I'm just going to clean up this session. Clear. Do a web search of Nginx. I wanted to do not fetch, but do a web search tool where web search is defined. There we go. For Nginx output, web search, this one uses DuckDuckGo. and it tells me about the official site. It tells me about downloads, and then I can say, hey, fetch. Sorry, I need to be very specific with this OpenClaw because this is running a very small model. Just for a demo, it's running Qwen 2.53 billion model. So there's like a 2 gigabyte model so that it fits into an old laptop that I'm using. It's a laptop with a RTX 3060 in it, which has 6 gigabytes of memory. So this is proof of concept, not a functional thing. I also limited the tokens to max token input and output is, I don't know, very, very low number because this only has 32K tokens. So yeah, I gotta be specific. Web fetch, the first 200 words from https nginx.org. Let's see if it's gonna work. To 200, first 200 words, we got it, right? We got the words coming out. Now let's say the previous search was good. Look up on Nginx on the web using https google.com, and that should fail. That should fail. I'll explain why. We'll look at the design. Okay. That's its context capability. Okay, let's look at this one again just to see. Look up Nginx on the web. Not using Google. It's not using Google. It's using DuckDuckGo. It's actually using DuckDuckGo here. So let's do this. Web fetch. 200 words from Google. Let's see if this works. Stop committing to memory. This OpenClaw, when you have such a small model, it does really weird things. Let me just quickly clear, and we're gonna do this fresh. Oh, this is stuff that happens live. This is stuff that happens live where, all right, tool web fetch error. So it said, yep, nope, it's not working. It's giving me an error. There seems to be an issue with that URL. And if we go and say web fetch the first 200 words from Nginx, hopefully it's not going to read from memory. It's reading from memory. Probably, oh, there we go. Read web fetch. It does web fetch from nginx.org, and we saw that it works with DuckDuckGo. Why does it work that way? Well, because what I did was I created just an allow list saying default is 0, Nginx, www.nginx, DuckDuckGo are allowed domains, and everything else is not allowed in the platform itself. So if I were to comment out these things, then obviously we would be able to do this. All right. So what we're gonna do is I've already have a chat window set up. Get the latest data from hotel in the table. So this was before. You can see 42. That was about 20 minutes ago. These are UTC numbers. So right now it should be 3 p.m. in UTC, 3 something time in UTC, 3:19 p.m. There we go. It's going to pull the last batches from the hotel spans and tell us, hey, the latest traffic from just now to DuckDuckGo, we had a 200. Google outbound request, we had a 403. Google outbound request, we had a 403, and nginx.org, we got a 200. So essentially what I'm doing now is I have full control. I have, number one, I have full visibility where it's connecting to. So for example, if we look at the previous logs, we can see all the outbound requests. We can look at the inbound requests, where it was going and what the statuses were for each of them. By having OTel plugged into Nginx, number one, OTel is natively supported in Nginx. HTTP Connect is now natively supported in Nginx. I'm not decrypting any content that I'm rushing through. I'm just looking at the metadata, connection metadata. So this means that even if you were to deploy this in an environment where you can't really look into encrypted traffic, you could just say, okay, we're not looking into what you're sending, so we are compliant, but we're seeing where it's going. If you would want to, if you'd want to decrypt the actual requests and look what the request is and what data it carries, then you could do an SSL decryption in between. So with F5, we got Big IP SSL orchestrator that can do that. It's a really cool tool and really big enterprise tool, and can do that in a compliant manner. You can do that with open source solutions as well. MITM proxy is an option, but again, that requires you to manage that CA for MITM proxy. Again, makes it complicated. This is a simple and compliant way of tracking what OpenClaw is doing. We now get the question answered that my friend over at KCD was saying. What is it actually doing? Where is it actually going? We can see now. We can see on the network, and we're packing it as Kubernetes. Because we're packing it as Kubernetes, we also have the full control of our network policies. We got the full containerization, so we can make it strictly, strictly very limited to what resources it can access. We can give it its own volume and then access that volume as admin and take a look at what it's storing, what the data is. It gives us like the real underlying physical network security for our platform. So Kubernetes gives us, process isolation like it would, and then the Nginx proxy gives us that network isolation. You can then also put guardrails on top. You can run NemoClaw to have a completely safe environment for the actual model. So you can control what the model does, what it actually responds with, and put guardrails for the content moderation of the model itself. Here, we're doing basic underlying network security. A lot of you might not want to have content moderation. You want to use the raw model, see what capabilities it has, but you're worried about what it's connecting to and where it's connecting to. Hey, here's a tool that lets you manage that really easily. All right, this will become part of the Dev Central repository very soon. It's not at the state where it's ready to go yet. I still need to clean up stuff. I still have this secret YAML. It's nothing. It's just it's a stub. It just defines what we're doing here. It just doesn't have good instructions yet. So we're looking at version 0.14. I'm not going to give this out, but it works at this point. It works. I want to also make sure that I can run it on multiple platforms. I can compare how it works on multiple platforms. This right now is running on an old laptop. So this is a MSI laptop from 2021. It's got a RTX 3060, 6 gigabytes of memory. These are running for like $400 or $500 Canadian dollars right now. So turn that into your own currency. But I've seen like a couple of these run for $300. So how much is that? 300 Canadian dollars to US dollars. It's about $200. And I've seen one for 150, so about 100 US dollars, that had a screen that was cracked. Cracked screen laptop is an awesome opportunity to help you out with. You want to run a model in very cheap manner. If you want to run it efficiently, that's a really, really cool way of doing things. And I did do a comparison on LinkedIn. Let me quickly show that LinkedIn post to everybody. That's something that I forgot to prepare here. It was a few weeks ago. at this point, but there were some really cool findings. I was testing different platforms. There it is. All right. Let's take this one. Let's take this post here, and I'll just bring it over if my browser will allow me to do so. Please, browser. All right. All right, so there we go. We're just gonna bring this over like this. So I tested the hardware that I have access to, easily have access to, and this is where the laptop with the 3060 came out. Tokens per second, it was able to pull 113 tokens per second. This is an average of many runs of actual tests. I am running a small model here. Again, I think it was Quen. It's a super small model. How do I open this? How do I don't know how to open. No, not the profile. I want to open this post. Anyway, I don't know how to open this post. I'll share it when I figure out how to open this post. But the key learning here is DGX Spark, super powerful thing, 128 gigabytes of unified memory. If you're going to be running a large model, you can push it to, this tiny little model was able to do almost 100 tokens per second. A larger model, you're going to be able to push it to like 60, 70 tokens per second, which is very, very good, right? It's not really fully real time. It's going to take quite a little bit of time to figure itself out. When you're using something like a web model, when you're using Claude, then you're looking at like, you can just see the tokens. You can see like 200, 300, 400, 500 tokens per second sometimes. So not 200, 300, 500, not really. But yeah, so then you're comparing that to a proper big GPU. So these are my two GPUs that I do testing on. I bought this a long time ago, right before COVID started with a 3090. As the card was released, I was able to snag one, and then I bought this one later on. Bought similar performance, 250 plus tokens, easily like real-time communication. But then when I measured tokens per watt, well, then the GPUs, the bigger GPUs like 3080 Ti and 3090, they're in the same class. They're like the same, basically, right? You got 3/4 of a token per watt. Now DGX Spark, 1.4 tokens per watt almost, but the RDX 3060, the mobile laptop, did a better token per watt comparison. So if you're going to be using something, you want a cheap platform to run a small model, get an old laptop. You can get it cheap. You can get one with a cracked screen. As long as you can put Linux on it, as long as you can run Olama on it, you can run it really, really cheaply. Yeah, and that's all I have to show. This was a quick show and tell of two things. Nginx Claw coming soon to Dev Central once I deem it to be good enough. And then 300 multiple choice KCNA questions also coming soon to my GitHub. And it was lovely to have everybody back to these sessions. We are going to skip next week's session because I am going to be away as well. So look forward to future sessions continuing in June. And thank you for attending today's session. It is my pleasure to talk again, to be able to talk again. Wasn't able to talk for 2 weeks. So yeah, enjoy. I'll see you next time. Bye.